So, now we will discuss uniform motion. See here, uniform motion in a straight line. Now, see here, in this case body is travelling along a straight line. So, when a body travels along a straight line and covers equal displacement in equal intervals of time, its motion is said to be uniform. In this case, in uniform motion, its velocity or speed remains constant throughout the motion, and also average speed is equal to instantaneous speed. Suppose now take here, this point is origin here. From the origin we are starting everything is here. So, you have chosen origin at the point O, that is a reference point. Now, at any instant body is at here t equal to 0 time, the body is at A. At t equal to 0 body is at A, and initial position from the origin is, that is, x naught. Now, after some time body is coming to the point B at t is equal to t1. So, in t1 time the body has reached to the point B, and this position has changed from x naught to x1 from the origin. Now, take again at any time t2 body has reached to the point C, and this distance from the origin or the position of the body at time t2 is x2 here. So, let velocity of body be v. So, we can write here x1 is equal to x naught plus v into t1. It means x naught 1 is equal to this distance plus this, and this is the distance v into t, simply the velocity into time or speed into time. Similarly, we can write here x2 is equal to x naught plus v into t2. So, this is the x2 is the position of the C, or you can say the total distance x2. Now, in this case we can take it here further. If you take is x2 minus x1, subtract these two, you will be getting just v into t2 minus t1, because this x naught is common, that will get cancelled. So, here we can write v is equal to x2 minus x1 upon t2 minus t1. So, this is the velocity is equal to x2 minus x1 upon t2 minus t1 in the time interval t2 minus t1. Now, here if you take further, or you want to write position x2, you can write x2 is equal to x1 plus v into t2 minus t1. It means position x2 is equal to this formula. So, this also can be used, this directly we can use, and also if we take x2 minus x1 is equal to, suppose, s, and t2 minus t1 is equal to t, then you can write v is equal to s upon t, or s is equal to v into t. So, when the body is moving in a straight line with the uniform speed, body is having, that means uniform motion, these relations are applicable. But see here in this case, certain important features of this uniform motion: displacement is equal to actual distance travelled by the body, provided body is moving in the given direction with the uniform speed, and direction remains fixed. Already we have taken in a straight line. Another one is here, velocity does not depend on, here in this case, the time interval, and also it does not depend on the origin chosen, where you have taken the origin. So, these are the factors which does not affect this, and also very important thing is here, average velocity is equal to instantaneous velocity. So, now we will come back to here position time graph for the uniform motion.